this section, I will describe the process for how I go about writing a query. In addition, I will also highlight when I'm likely to use temporary tables over permanent tables within a data warehouse. There are a number of ways that we can create a table in SQL. The first method is to create an empty table by defining in our SQL statement the table structure, such as field data types and indexes. Once the table is set up, we can then use an insert statement to populate the new table with data. The second option we have for creating a table is to use the create table as statement, which is then combined with a select statement. The as implies that the structure of our new table will be the same as the data types returned by the following select statement. You then have the option to apply indexes and keys to your new table. Tables can be defined as being permanent or temporary tables. The main difference between a permanent and a temporary table is that a permanent table will have data written to the database hard disk, and data will persist after a user or system session has closed. While a temporary table will use the database's memory, that is the RAM of the database or data warehouse server, and any data that is written to a temporary table will be deleted once the user or system session is closed. As an example, we have been asked to write a query to calculate sales figures to run on a weekly basis. The following is a breakdown of the development process I would typically follow. I will first find the output table for which the results of my analysis will be stored. In our given scenario, I will create a table called aggregate weekly sales, which will store a high-level summary of customer and financial details for a given week. Next, I will create a permanent table with a small sample set of customers, which I will use for testing at each stage of my analysis. As I'm using permanent tables, if I cannot finish the analysis in a given day, then I can come back to my analysis at a later stage, and I will still be able to access the same set of sample customers that I stored in my permanent customer sample table. For this example, I will assume I only need to set up one additional intermediary table to store a detailed list of customer transactions. But in reality, for such a query, you may require a number of intermediary tables to calculate a weekly sales end figure, such as a table to hold refund details, credit card chargebacks, currency conversions, and so on. Once again, as I'm using permanent tables, I can come back to my analysis at any stage that I choose, and disconnect from the database without any fear that I will lose my work. However, if I was using temporary tables, as soon as I disconnected from the database, any tables or results that I have created will be deleted from the database as they are stored in memory. And the next time I log back into the database, I would then need to recreate or rerun the steps of my analysis. Moving on, once I'm satisfied with the intermediary steps, I can then finally perform a query and output the required weekly sales summary into the table I initially created, aggregate weekly sales. I can then move on to the next stage, which is to run my queries against a full set of data. Ramping up my query, I identify that on any given week, our company is processing over 1 million customers with in excess of 10 million transactions. As we initially ran our development on a small sample set of customers, our initial development time was significantly reduced, whereas if I had started our analysis without defining a small sample set of customers, our development time would have been significantly greater, as for each step along the way we would be processing millions of transactions instead of only a handful of transactions. Next, I check the performance of the queries by reviewing the explain plans for the full set of data. I can apply some performance tuning, which is typically in the form of adding indexes or keys to intermediary tables, and also applying additional criteria where required, such as by defining dates to reduce the number of rows, and also focusing in on areas such as customer segments or country codes, where I may, for example, only want to pull information based on one country such as the United Kingdom or the United States. Adding in such criteria can reduce your query time significantly. Once I'm happy with my overall results, I will then go ahead and schedule 2 test runs of my queries in production. The first test run will use permanent tables for our intermediary steps, and at the end of the test run I will go ahead and drop or truncate any intermediary tables used in our analysis. The next time we run the scheduled job, we would then need to create our intermediary tables again if we have dropped them, or check that they exist and are empty. The second test will use temporary tables for storing intermediary results, and almost 9 times out of 10, I find that using temporary tables are much faster, as results are written and read from database memory, as opposed to a database's hard disk, with the resulting output being only a few rows of data which we need to store in our aggregate weekly sales table. In other words, the most expensive part of our query, if we use permanent tables, would be the read and write time for the 1 million customers and their corresponding 10 million transactions to the database's hard disks. In addition, the database would also need to identify where such records can be written to the database, and if we have not set up appropriate indexes or partitions for the data, retrieving the intermediary results for our query can take a very long time. In some cases, I've seen queries which have taken up to 10 hours to run in production reduced down to 10 minutes by switching over to temporary tables, where the data warehouse has sufficient enough memory for processing our queries in memory, as opposed to writing to a hard disk. However, there is the occasion where temporary tables may not be sufficient to use, and this is likely to be where your data warehouse does not have sufficient enough memory or RAM to write intermediary results to. In these scenarios, we would then need to write our intermediary results to permanent tables, which will be written to the hard disk of the database or data warehouse. For most data analysis, you will also find that you're not dealing with live production databases and are in fact reading data from a copy of live production tables. So also to note that if you are performing analysis such as a scheduled weekly job, that you may be missing a few days worth of data if there is a delay in writing results from the live production system out to an intermediary development data warehouse. To summarize, having the means to create intermediary tables means an analyst can break down their queries into smaller compartmentalized queries instead of trying to write one very large query, which will be very difficult to test and debug for issues. Finally, I've also provided a small reference table with some of the considerations you should take into account when choosing if you should use permanent or temporary tables in your analysis. As noted at the beginning, I will work backwards from the results I'm trying to obtain, instead of trying to work forwards through all the criteria. So knowing the given outcome of your query at the beginning is an ideal when performing any analysis. Let's now move on and take a look at some live coding examples.